To make highly technical ceramic components, it all starts with powder.
At AMP, we start with powder and we end with powder.
In this episode, we explore the science and engineering behind the ceramic powders used in our components.
That powder has a lot of added value. That powder has the right formulation to make the right ceramic with the right properties.
By controlling everything from the molecular formula to particle size, we manage how our parts perform in the applications they're designed for. It all happens in a process we call advanced materials processing. Ceramic components are everywhere around us, from space exploration to energy production, even in our homes and cars. Our experts guide you through the basics of engineered ceramics, from how they're made to how they're applied. I'm Scott Thompson, R&D Manager here at CoorsTek. Welcome to Ceramics 101. Before we make ceramic components, we engineer the ceramic powder that goes into them. It all happens here at our new state-of-the-art facility in Golden, Colorado. CoorsTek uses raw materials from around the world to make the powders used in our ceramic components.
We bring in 110 different raw materials and chemicals from at least 6 of the continents.
Our portfolio of formulation is really wide, and that is because each application really requires a different formulation.
As the raw materials arrive at our facilities, they are tested for quality and purity.
Raw materials are so important that I have a specific department that tests and qualifies those materials.
We add our raw materials in water in specific amounts to the ball mill for mixing and particle size reduction.
Ball milling is basically a large cylindrical vessel, and we put large balls in it. We put a powder, we turn that cylinder for a certain amount of time to get the right particle size for that particular formulation.
The particle size is very critical because it could affect the mechanical properties, dielectric properties, the resistive properties.
The thick liquid, or slurry, that comes out of the ball mill is pumped into a slurry tank where we mix in binders and other additives.
The binder acts as a glue between the ceramic particles and help the powder stick together and form into intricate shapes.
With the binder added, the slurry is spray dried into a flowable powder.
The spray dryer has an atomizer or a nozzle that is very similar to a garden hose, and the droplets are wet and then they go into a heated dryer.
The first component of the spray drying is to get the water out of the system, and the second is to give it a specific size and distribution so that the powder will have the powder properties or the flow properties that we want.
Powder flow gives us the ability to make consistent parts. Raw powder by itself doesn't flow well. Due to static attraction, it clumps together like flour. One of the reasons we spray dry is so it flows better, more like granulated sugar. After being spray dried, the material is characterized so we know the physical and chemical properties of every batch of powder we make.
It's the final proof that the material is good before it then gets processed into a part.
The material is now ready to be sent to CoorsTek facilities worldwide.
We have the capacity to fulfill any of our customers' requirements with a lot of room for growth.
Advanced materials processing is critical to producing superior ceramics. In the next episode, we'll learn about forming ceramic powder into parts. See you then.